Hello everyone, myself K. Today we are going to see the problems on center of gravity. Now just see the problem statement. Most of the center of gravity problem you will not get the diagram, so you have to draw the diagram. So just read the problem statement so we can draw the diagram. Find Now just see the problem statement. Find the center of gravity of the composite solid in which solid cone having the base diameter 100 mm and height 200 mm is placed on the base of the hemisphere of the same diameter. So diameter of the cone and solid sphere is same. So height of the cone is 200 mm. You can see that the cone is placed on the hemisphere. So for the placing on the hemisphere must be lie like this, and on which the cone is placed. So we have drawn the diagram like this. Hemisphere or cone is placed in the on the hemisphere. Now just see, this is the hemisphere and cone and axis of symmetry. The object is placed in the first quadrant. First object is taken as a cone and second object is taken as a hemisphere. Here is the G1 and here is the G2, center of gravity of the cone and center of gravity of the hemisphere. As you can see, this object is symmetrical over this vertical axis. So as the object is symmetrical about the vertical axis, so its x bar we can directly get is equals to 100 by 2, that is equals to 50 mm, or half of the work is done over here. So just we have to find out the y1, y2, v1 and v2. Now just see volume of the cone and hemisphere. Now first of all, hemisphere or volume V2. Just see formula for the V2 or hemisphere, 2 by 3 pi r cube, 2 by 3 pi into 50 cube. Now just see the digit, 83333.33 pi mm cube. In the previous problem or in the previous video, I have told you that you need not to multiply by pi, because unnecessary our digit will be increased. So here you can observe that digit will be increased after multiplying the pi. So just keep it as it is. You can get it can be gets cancelled in the next steps. So cone, for the cone, v1 is equal to 1 by 3 pi r square into h, that will equals to pi 1 by 3 pi, and just put the values 50 square into 200. So this will be 50, it will be into 200. So v1 is equals to 16666.6 into pi mm cube. Now just see the center of gravity of this simple solids. You know that the for the cone it will be h by 4, but we have to add this 50 distance for the y1. So this y1 h by 4 plus 50, just see, and h is 200. So 200 by 4 plus 50, y1 is equals to 100. Now see, for the hemisphere, the y bar is equals to 3r upon 8, but 3r upon 8 is the distance from the center of the hemisphere. So in this problem, hemisphere is placed like this, facing in upward direction. So our 3r upon 8 distance will be from this point to this point. So we required y2 as a distance from this point to this point. So our y2 will be equals to 3r minus 3r upon 8, total distance r minus this distance 3r upon 8. So r minus 3r upon 8, 50 minus, so just putting the values we will get the value 51.25. Now for calculating the y bar, we know the formula v1 y1 plus v2 y2 divided by v1 plus v2. Just put the values v1 v2 and y1 y2. Just see the digits or huge digits, so be careful. So be careful while putting the values. So plus this divided by this, so just put the values, and y bar will be equals to pi gets cancelled over here, so y bar is equals to 77.08 mm, and centroid of the composite body will be equals to 50 and 77.08. 50 already calculated from the symmetry, and y bar is calculated over here, so cg will be like this. Okay, I hope you have understood the how to calculate center of gravity of this composite solid body. In the next video we are going to see or discuss next problem. Thank you. Thanks for the